Well, welcome everybody to the inaugural episode of Stars, Cells, and God. My name is Rana, and I'm joined by Hugh Ross, and we're going to be talking in this podcast about new discoveries that are taking place at the frontiers of science that have theological and philosophical implications. Discoveries that point to the reality of God's existence and the reliability of the Old and the New Testament. So welcome to this podcast, which is sponsored by Reasons to Believe. And so if you want to know more about Reasons to Believe, please go to our website, www.reasons.org. Or if you want to follow us on social media, Facebook, Twitter, or Instagram, RTB Official is how you would find more about our social media presence. Well, without any further ado, Hugh, we should probably get right into today's program. But maybe just a comment from you, a little bit about, why are you excited about this new podcast? What about this podcast really gets you going?
Well, it takes me back a couple of decades when we were doing Creation Update, where we were talking about, the latest scientific discoveries that were in the past week's scientific literature. And, we write blogs on this, but it's like, this gives us an opportunity to do more than just say a one-a-week thing.
Yeah.
We can talk about several. So
yeah,
people like to watch video. So it's like, hey, you can read our blogs, but we're not going to talk to you about it through this medium.
Yeah, this allows us to be much more responsive to discoveries that are happening, that are making the headlines, but also a chance for us to share with people discoveries that are kind of buried in the dark recesses of the scientific literature that have really profound implications for the Christian faith. And, one of the hallmarks of Reasons to Believe is that we do focus on the latest advances in science and what they tell us about Christianity. So that's really the spirit of this podcast. And we also want to really create an interactive experience for those people that are watching this. So please feel free in the comment section to ask questions. Feel free to post links to scientific articles that you would like us to comment on. Don't guarantee that we'll answer every question or do a discussion of every discovery that people link to, but this is a chance for us to get to know what our viewers are interested in, and we definitely will take that into consideration as we shape the programs.
Oh, the feedback's important.
Yeah. Okay, well, today, Hugh, we're going to each share some discoveries and offer some perspective on what those discoveries mean for the Christian faith. I'm going to talk a little bit about brain organoids and what they mean for the case for human exceptionalism and the idea that human beings are made in God's image. And you're going to be talking about a couple of discoveries involving the cosmic background radiation, right? So why don't you go ahead and take it away, Hugh, and then...
this is cutting edge. It's not even in the peer-reviewed literature yet, but it is available as a preprint. I read the preprint, and there's no doubt it's going to get published.
Yeah.
A lot of authors on it, and it's really quite a breakthrough discovery. And it's basically testing a part of the Big Bang creation model that had never been tested before. And, the Bible says 4 things about the universe. That it has a beginning, that includes a beginning even of space and time itself. That the laws that govern the universe don't change, they're fixed. And if you read Ecclesiastes and Romans and Genesis and Revelation, one of those laws is what's called a pervasive law of decay. Some translations call it corruption. We physicists call it the second law of thermodynamics. Lay people, maybe Murphy's Law, but it's just everything's decaying. And that applies to the whole universe. And then we also have the statement in 11 different places of the Bible that the universe is being stretched out. It's expanding. Well, the universe has a space-time beginning, starts off small and expands, where the whole universe is governed by thermodynamics. That universe will get colder and colder as it gets bigger and bigger. It's the same principle of your car engine. When the piston chamber expands, the gasoline stops burning because the temperature drops. And when the piston chamber compresses, it reignites. mean, you got diesel engines that don't even need a spark plug. They do it all with that thermodynamic principle. Well, that means that if indeed the universe has a beginning that's described by the Big Bang creation model, you're going to get a cooling curve that'll be predicted from that. And in one sense, the Bible predicts a cooling curve for the universe. Got a beginning, constant laws of physics, is expanding under thermodynamics. It's going to cool down in a particular way, assuming you know the age of the universe.
So, and you're not really saying that there are these, scientific graphs, of course, in Scripture.
No.
But you're saying is that if you look at the properties that are being described for the universe, then if you just simply look at the implications of that, it's essentially predicting that the universe would be cooling down. That would be the consequence.
Well, I remember I was doing a debate with an atheist quantum physicist at the University of Alberta, Calgary. He said, I want to see something from the Bible that I can look at and put to hard actual measurements. This is that one example. And if you could show the slide in the screen here.
Yeah.
Okay, so this would be what you would predict the cooling curve of the universe to look like, assuming the universe is 13.8 billion years old, assuming it has a space-time beginning, expands under constant laws of physics, or one of those laws is a pervasive law of decay. The little red circles show you measurements that have been made up until 2020. And you can see how those red dots are fitting the biblically predicted cooling curve. And we get really accurate measurements when we're at the present epoch. And then we have one really accurate measurement at about 7 billion years after the cosmic creation event. But what you can see, they perfectly fit. Now, as we move into earlier times, the error bars get bigger, but you still see that it's fitting the biblically predicted cooling curve.
And you would expect the error bars to get bigger as you're making those measurements in distant space, right?
Yeah, because you're looking at galaxies really far away, and it's hard to get a high signal-to-noise ratio, because how they're making these, they're looking at certain spectral lines, typically carbon or carbon monoxide lines, and those lines are rather feeble when you're getting to very distant galaxies. And so, yes, signal-to-noise is a big problem, which explains why we have error bars that you can't even see when you're 7 billion years up to the present. But once you get earlier than 7 billion years, the error bars get bigger. Nevertheless, it's fitting. Now, what's in this preprint is that they've been able to take it all the way back to 900 million years after the cosmic creation. That's that far edge arrow.
Okay.
I didn't have time to kind of pull the graph up high enough where you could see where the actual data point is, and the error bar is big. But once again, it fits right on that predicted cooling curve. And where you got a little more definitive, that's in this preprint right here, where they go back to, it's actually a redshift is 6.34, which corresponds to the universe only being less than 10% of its present age, 6%, 900 million years after the cosmic creation event. But I brought with me another paper that was published a year ago. That's this paper here. That represents the second arrow, where they were able to, because before 2020, the earliest we could go back was about 3.6 billion years after the cosmic creation event. And so astronomers say, I wonder how the Big Bang will hold up when we make measurements earlier than that. Well, this paper published a year ago, they got a whole bunch of measurements between 2 billion years after the cosmic creation event and 6 billion years. And they all had rather large error bars, but they had like 17 measurements, because they looked at 17 different galaxies. And so what they do is they collected all that data, and based on that data, they were able to extrapolate, assuming the Big Bang creation model is correct, they're able to extrapolate back to the temperature you would get at the present epoch. Now, we got a really accurate measurement of that thanks to the Planck satellite and then the WMAP of the cosmic microwave background radiation. But I'm going to read to you just how well the two compare. And so what you get from the Planck satellite is 2.7255 degrees above absolute zero, with an error bar of 0.0006 Kelvin. So that's really accurate.
Yeah.
Okay. But when they did this extrapolation and were able to drive independently the temperature you would have today, it came in at 2.710 plus or minus 0.009. So it's a perfect fit.
Yeah, that's amazing.
Yeah, really amazing fit. So this qualifies as yet one more test of the Big Bang creation model. And now we got to push back all the way to just 900 million years after the cosmic creation event. And I show people this graph. This is, I think, the most explicit demonstration for lay people we must be living in a Big Bang universe, because only a Big Bang universe would give you that predicted cooling curve. And the fact that the measurements fit so well means we can be really confident that the Big Bang model is correct. And that means that what the Bible says about the universe likewise is correct. And if you go to our website at reasons.org, I got 2 articles on how the Big Bang predicted not all the elements of Big Bang cosmology, but the 4 most fundamental ones.
Yeah.
And of course, a lot of astronomers say, hey, Hugh, you're reading this into the Bible from hindsight. You're a 21st century astronomer. So I got another article where I say, hey, look at these Jewish and Christian theologians writing 1,000 years ago, 800 years ago, 900 years ago. They were seeing the same things in the Bible. So it basically demonstrates the Bible really does declare that. And frankly, I've found even atheists, when they look at the Bible, they do admit the Bible tells us an ex nihilo creation event. The universe being created out of nothing, including space and time. The laws of physics are constant. And one of those laws is a pervasive law of decay. Even those 3, that's Big Bang cosmology. So,
Well, and from a kind of a philosophical standpoint, this kind of discovery really supports the notion that that there must be a cause outside the universe that brought the universe into existence, right? If the universe, if something begins to exist that must have a cause, the universe begins to exist that must have a cause that has to be, by definition, greater than the universe itself. And that's how Christians understand the idea of God.
Well, you got Hebrews 11:3. The universe that we can detect did not come from that which we can detect. Well, what can we detect? Matter, energy, space, and time. And the Bible tells us those all had a common beginning. So it means that the creator of that matter, energy, space, and time must be a being or an entity beyond matter, energy, space, and time.
Yeah, well, one of the things that I think is interesting is that regardless of your worldview, you ultimately have to posit an uncaused cause that explains the beginning of the universe. Because, it's oftentimes skeptics might say, well, then who created God? Well, the idea is that Christians are positing God as being an uncaused cause. But if you are arguing for the multiverse or some kind of fluctuation in an eternally existing gravitational field or something like that, right, you're still appealing to an uncaused cause. The question is that uncaused cause personal or impersonal? How would you react to those comments?
I love it when skeptics throw that question at me, because it says, that's a powerful proof for creation. Any entity constrained to a single dimension of time, where time can't be reversed, has to have a beginning, has to have some kind of creation point somewhere along that line. Ultimate. I mean, you could say maybe there's a secondary cause, but ultimately there has to be a cause somewhere along that timeline. But a creator that's got the power to create space-time dimensions at will isn't subject to that restriction. And so any entity constrained to our universe has to be created, has to have some kind of ultimate beginning, but the one that created space and time, that does not apply.
Yeah. So that objection seems to have thrust or seems to have merit simply because as beings we're confined to a single dimension of time, but that then limits how we could potentially think about entities that aren't like us.
Yeah, I mean, if you're like Carl Sagan and think the universe is all there is or was or ever will be, then you got a problem, because any such entity has to have some kind of ultimate beginning. So in that sense, it's self-defeating.
Yeah, yeah. Well, anything else you want to share with us about this discovery?
Well, I think these two discoveries together, I mean, as you look at that graph there, it's like, okay, now we really got a complete picture of the cooling of the universe that indeed extrapolates right back to when the universe would be near infinitely hot and nearly infinitely compact. So I got another one I can talk about, completely different, but I want to hear from you about these brain organoids.
Oh, okay, okay. Well,
I mean, how many do I have of them up here?
Well, that's not what brain organoids are, but
I'm just joking with you.
Yeah, but just for a little bit of fun, I don't know, Hugh, have you ever seen the movie Young Frankenstein? I would be surprised if you did.
No, I've not seen that one.
Well, it's a movie that I watched when I was a young man, and it was a Mel Brooks movie, a spoof on kind of the Frankenstein, story, and it's a horror comedy, and it starred these comedians of note like Gene Wilder and Marty Feldman and Peter Boyle, and
you got Mel Brooks writing the scripts.
Yeah, yeah, and so it's a totally inane comedy that's absolutely hysterical. But one of my favorite scenes in the movie is when the Gene Wilder, who plays Dr. Frankenstein, he doesn't want to be. It's not Frankenstein, but Frankenstein, and he's the grandson of Victor von Frankenstein, and so he's trying to follow in his grandfather's footsteps and bring a monster back to life, and so he has an assistant named Igor who he dispatches to get a brain for the monster, and things aren't going well, and so he's beginning to ask Igor, so what brain did you actually give me? And he says, well, it came from this person named Abby Normal, and and so anyway, that came to mind as I thought about this particular discovery I want to talk about, which is work done a little bit about close to a year ago now by a team from UC San Diego who were creating these brain organoids, and they actually, through genetic engineering, created a Neanderthalized brain organoid. So they were essentially using this cutting edge technology to try to essentially recapitulate in the lab elements of the Neanderthal brain. And so it's really remarkable cutting edge science that was done first and foremost to just see what this technology could do from a biomedical standpoint, but then secondarily to really try to shine light on the question, how do humans compare to Neanderthals? Are we, unique and exceptional, or were Neanderthals like us? So it's a really interesting, very powerful experiment that these researchers did.
Right, and so what was the raw material they started with?
Yeah, well, maybe this is a great chance just to talk a little bit about brain organoids. And this is a relatively new technology. And this is kind of a complicated slide here. I pulled off of Wikipedia, by the way. But the idea is that you take either embryonic stem cells, induced pluripotent stem cells. You can take things like neural crest cells that are unfortunately harvested from fetal remains. And in the laboratory, you can get them to grow into cell cultures that begin to mimic neural tissue. And these are three-dimensional cell cultures, so as they grow them, and it takes a couple of months to grow these, they slowly rotate them in these bioreactors, and that rotation causes the culture to form a three-dimensional structure. And then by varying different types of the media, different growth factors, you can actually coax the cells into developing into different types of neural cells. And so through this technique, you can create these little cell cultures that are several millimeters in size. They're not much bigger than that. There's no blood supply, so they can't grow much beyond that point. But they begin to mimic different regions of the human brain depending upon the types of growth factors you use.
So they're basically growing stuff that's about 1 millimeter in diameter.
Yes.
And trying to do it in such a way that they're able to mimic different brain functions in different parts of the brain.
And so this is a great technique that allows researchers to gain understanding about, neural development, particularly in humans, and also it's a powerful tool to study neurological disorders, particularly those that are of a genetic basis, because you can take cells from a patient with a neurological disorder and actually grow these brain organoids and compare them then to organoids grown from, quote unquote, healthy cells. And so this research team thought that this might be a powerful approach to actually gain an understanding about the brain of creatures like Neanderthals that are extinct that we can't study, right? And what they ended up doing is focused on a gene called NOVA1. And this gene is involved in brain development. And it turns out that when they survey the genomes of humans, modern humans, compared to Neanderthals and their cousins, the Denisovans, they discovered that the NOVA1 gene in Neanderthals is a different variant than what you see in humans. And so they thought, well, since this controls neural development, then obviously this implies cognitive differences. But what if we use gene editing to actually take a human brain organoid, or at least the cells used to grow a human brain organoid, and replace the human version with the Neanderthal version?
Okay.
So it's a a really interesting experiment. And so then they grow.
Now I know why you started with Frankenstein.
Yeah, that's right. Yeah. Well, and so what they discovered is that the human brain organoid was spherical. It got to be larger than the Neanderthalized brain organoid, and it had a smooth surface, whereas the Neanderthalized brain organoid was smaller in size. It was more irregular in shape, and the surface was kind of bumpy. It was an irregular surface too. But they also saw that the cells in the human brain organoid grew at a much faster rate than in the Neanderthalized brain organoid, and they discovered that the gene expression patterns were different in these two cell cultures, at 1 month and at 2 months. So the implication here is that not only is the NOVA1 gene different, but that when you actually look at what the implications of that are, you see that you see these brain organoids actually behaving very different. Mm-hmm. And so you got to be careful here about how far you draw conclusions, but this is suggestive that there are cognitive differences in humans and Neanderthals, and that those cognitive differences are consistent with the idea that humans are exceptional in our cognitive capacity compared to Neanderthals.
Yeah, and imagine too, you get a different developmental history as well.
Yes. Well, this is interesting because the human brain and the Neanderthal brain were really different shapes, even though both brain sizes were comparable, in humans and Neanderthals. The brain structure is different, and we know that from studying the skull of modern humans. Our skull and face is really bizarre. We actually have an abnormal brain compared to the other hominins. So our brains really are abnormal, and in that our skull is globular, our face is flat, our chin is retracted, and that causes our parietal lobe to expand. In comparison, Neanderthals had an elongated skull, which means their parietal lobe is underdeveloped, and their face is not flat, and their chin is it extends outward. And so this indicates a difference in brain structure, which very well could translate into differences in cognitive ability. But what's interesting is that we have enough skeletal remains of Neanderthals that we can actually monitor the growth and development of a Neanderthal from an infant to an adult. And the brain is elongated at the very onset. The skull is elongated, and it doesn't change its shape. Interestingly enough, when human infants are born, our skull is elongated and our brain is elongated. But as we grow very rapidly, there's a globularization that happens to our brain. So it happens very quickly. So the developmental process in humans and Neanderthals is very different. And there's other genetic studies that people have done, similar to the Nova-1 comparison, that genes that seem to be involved in neural development or that are implicated in neurological disorders are different in humans and Neanderthals. And the gene expression patterns are different as well. So when you put all of this together, I think there's a really powerful case that can be made that our cognitive abilities were different in humans compared to Neanderthals, and that we stand apart from the other hominins, not only in our brain size, but in our brain shape and even in the genetics that undergirds our neurological growth and development. And so to me, this is kind of providing a biological basis for the claim that humans are exceptional.
I really like what you're saying about what happens to a newborn human infant, just how quickly the brain shape changes. I mean, I got to see that my sons, literally within months, you can see that change. What you're saying is that doesn't happen with Neanderthals.
Right. There's no indication that that's the case whatsoever. And of course, one of the things that really defines us as human beings is our capacity for symbolism. And an expanded parietal lobe would support what we would need to express, to characterize the world symbolically and then to express ourselves
and
symbolically.
Children get that at a very early age.
Yeah.
I mean, look how rapidly our children are able to communicate in sentences and paragraphs.
Right. And it's controversial if Neanderthals had the capacity for symbolism. And so for me, as a Christian, I take the view that human beings uniquely bear God's image. And I think one of the ways in which that image is manifested is in our language capacity and our ability to not only take the symbols that we can use to represent the world, but to manipulate them and combine them in near infinite ways to really tell stories. And there, again, it's controversial if Neanderthals had this ability. Some people claim yes, others claim no. But that to me, again, is a manifestation of the image of God. And so anything that we see scientifically that supports human exceptionalism, in a sense, could be used to support the idea that humans uniquely bear God's image.
Now, is there any hope that we're going to get similar results by looking at the Denisovans?
Well, the Nova-1 gene is actually the same.
It's the same
in Neanderthals and Denisovans. And so, technically speaking, what they were looking at was really the brain organoids for what you might call archaic hominins, right? Which would include, Neanderthals and Denisovans, right? So, yeah.
And how about the medical, because I'm thinking of neurosurgeons, they're working on the brain. I think this kind of research is really going to help them. Okay, this part of the brain we better leave alone. This part we can safely take out, and the person will be able to adapt. Did the authors mention any of those possible applications?
No, but the people are looking at, looking at brain organoids again as a very powerful research tool for biomedical purposes. There are also people that are doing, experiments on the order of Dr. Frankenstein, where they're taking human brain organoids and then implanting them into the brains of mice or other animals. And so they're creating what we call neurological chimeras. And part of the reason to do that is because in cell culture, you can't really provide a blood supply, right? And so that limits the lifetime of these brain organoids in their size and the developmental complexity. And so by putting them in the brain, in like a mouse brain, implanting them, you actually see the blood supply blood vessels supplying the brain organoid. Of course, that opens up all kinds of very interesting ethical questions.
Well, it does, but as you know, my younger son is a clinical neuropsychologist, and he's with a group that's talking about, is it going to be possible to take a tiny snippet of brain tissue out of, say, someone who died in a motorcycle accident and be able to put it into someone who has a brain misfunction going on and repair that misfunction?
Yeah.
So, I mean, I know that's really emerging stuff, but...
Yeah, well, I mean, that's interesting because you could easily envision these brain organoids being used in that way.
Yeah, but all you need is a millimeter to fix a brain disorder.
Right. It's probably at this juncture not a one-to-one comparison, but that's the type of thing that could potentially be done with the brain organoids. So
what you're saying, they're already doing it on mice.
Yes.
Yeah. So there's hope. Maybe 20 years from now, when my brain gets really decayed, I can get it fixed. Talk to Dr. Frankenstein.
Right.
And I got one for you in that too. It's like I was talking to this mountaineering guide, and he was telling me, I've been reading this thing about there's new technology coming where they're going to be able to transplant a brain from one person to another person. But it comes at a cost. If you want a brain like Einstein's, you're going to have to pay a lot of money to get that transplant. But he says the most expensive one of all is to get a brain from a mountain guide because it's never been used.
Right. Well, I think on that note, we probably ought to bring this to a close. But again, thanks for watching this inaugural episode. If you've got any kind of feedback or suggestions for us, love to hear it in the comments. Please, if you've got questions or you've got discoveries that you want us to talk about, please put them in the comments. We definitely will pay attention to those comments. And please check out our website, reasons.org, where there are tons of resources available to you.
Not tons, but tens of thousands of articles and videos.
Yeah. Right. So a lot of stuff. That will help you engage in the science-faith conversation.
It'll stimulate your brain organoids, right?
That's right. That's right. And then, of course, don't forget to follow us on social media, RTB Official. That'll get you to our Facebook and Twitter and Instagram pages.
And all of our scholars have individual Facebook and Twitter pages where we take people's questions.
Yeah. So we want to hear from you. So again, thank you. And just remember that, as we like to say around here, Hugh, the more we know about science, the more we have reasons to believe.
Amen to that.